And we're live.
Great. Hey, it's been a while, Alex.
Yes. Welcome, everyone. Welcome to ChanceTALK 26. It's been a few months since we've done the 25th version with Sam. Sam, welcome.
Thanks, Alex. And Alex has got a new system now, and so I can't get my background up. So for you folks at home, because I have a green screen, you can substitute any background you want for me. Put me on the beach somewhere.
Or a flat dice.
Yeah, exactly.
Well, so it's been so long since we last spoke. I have been doing some absolutely amazing things with Sip MTH because I finally found a place for it, and my God, my life has changed forever.
Because that's what I want to hear about that. In fact, you know what, Alex? I've been teaching for years. The wrong way to teach stuff is teach the theory first and then the application. No, you should always see the application first. Then I will have some things to say about the overall scope of what we're doing. So fire up.
Yeah, actually, let me start with just my experience over the last few months, because I've been doing quite a few Sip MTH models, and if that's not a revolution in risk management, I don't know what is.
Yeah.
And you've only been talking about this since 2019 from the first Risk Awareness Week. So 5 years in, I think I'm on the same level of excitement, and I hope our ChanceTALK sessions going to share that excitement with the general public, because here's the kind of the groundbreaking difference for me. The risk models that I used to do used to be black boxes limited to the computer of a risk manager. So I would take somebody's business plan, and then I would substitute all the assumptions with distributions. I would set up correlations. I would run a simulation, but that model becomes unusable for anybody else in the organization unless they have the software. And because it's license per user, the finance department doesn't usually have the software, and the CFO and the CEO is not going to open and look at the modeling results to appreciate what sort of conclusions we're coming up with. So normally you would have to kind of copy paste the reports and from risk software into a Word document or a PowerPoint, and then this is nice when you have static models, but that's never the case when you're supporting live decisions that are literally changing and being updated until the very last second before the executive presentation. It's impossible to take away the model, manipulate it, and then say, freeze everybody, I'm doing the risk analysis.
Yeah. Hold on, I got to take notes. Just a minute. I want you to just keep going.
Yeah.
You said static models, right? Just keep talking, Alex. I'm just trying my clipboard here.
So I've ever since we first met many years ago, I was really, really excited about the fact that you can continue using the same Excel file, the native Excel file, and make it stochastic, make it probabilistic at the same time. And this was just something unthinkable when we were using all the common risk modeling tools, because as soon as you touch somebody's model, they can no longer use it. It just becomes I don't know what analogy.
It becomes a fossil.
Pretty much. And the worst thing of that is that not only they cannot use it, the business doesn't stop just because you wanted to do risk analysis. They continue to update in the model, and so you're already basing your risk analysis on the outdated version of something that has changed 10 times since they sent you the file. So that was an issue that I've been facing in the past. And using Sip MTH standard now allows me to take existing Excel file, make it stochastic, send it back, say calling it an interactive calculator, saying continue doing what you're doing, make whatever changes you need to the file, and it just recalculates automatically and gives the chance of success, or for my specific needs, we were doing expected values versus expected contingency, P80, and kind of worst case contingency. So I actually wanted to show a very simple model, something that I think for the first time ever in my career, I had no trouble implementing in the business. Like I would send it to the CFO or the CEO or the head of strategy or the head or the finance director, and they would say, "Great, we're going to use it." And they would put it, take the conclusions from the risk model and update it. And whenever the risk model needs to be updated, they would update it themselves and kind of recalculate the values. I've even put some of my models on the cloud, so anyone in the company can update the assumptions and just pull out the kind of the new contingency calculation. So let me show this one thing that I did, which I thought was really exciting. So and this is for everybody who's watching us. This is as basic as it gets. Like this is kindergarten level risk management.
Can you blow the screen up a little bit? I can't quite read the numbers.
Sure. Well, the numbers are just an illustration. This is basically like a list of costs, like a budget estimate for a given year, like some sort of forecast for next month or next year. And this is what the finance sent me. They sent me, okay, this is your 1 year forecast, some things related to operations and some general costs. And here's the kind of the total cost and cost per location. So it sounds pretty generic. And then the first thing that Sip Math allowed me to do is to say, okay, well, what if we add some of the volatility to the assumption? And for the purposes of this exercise, I'm assuming that number is an assumption, because in reality, it actually isn't. It's the result of the calculation because, for example, the reagent costs or power consumption is actually a product of volume of product produced times the price of, and the actual model is much more complicated. But even at this aggregate level, when you're short on time and you want to add some sort of contingency, but you don't have the time or the competency to to go through the proper, bottom-up modeling, you can go with something that AAC is doing for project management and project contingencies. You can really go, okay, well, so what sort of uncertainty do I have on different line items? How confident is the team?
Got it. Is that like that's like your 95% confidence interval, sort of?
It depends on it depends on what distribution you use. For me, it actually became so. I've done some consultation with the team and I said, okay, this is approximately how we feel about each of these assumptions. Some are more uncertain than others. And then what I've done is, again, because this is kindergarten level, very simplistic, and by the way, the whole thing took me maybe an hour, maybe hour and a half. But like this is, I think, the future of risk analysis. Like we need to calculate contingency, and it has to be an MVP. So it has to be something very simple, very straightforward. How do we do it? And I've converted this. So I take 3 as my original value, and then I go min max as the 0th percentile and the 100th percentile. Based on the ranges that they've told me. If I was kind of doing it properly, I probably would have made it P5 and P95, P10 and P90. But for the purposes of the kind of this illustration, what I did is then I used Sip Math Monte Carlo to turn these 3 numbers into a simulation. So this cell now has the full distribution, the birth distribution, representing this uncertainty. And
what are you using in there? Is that like a beta PERT or something, or
it's a birth distribution.
Yeah, perfect. Got it. So far, by the way, the model looks beautiful, and I love the way you're pulling back the kimono here. You
Yeah.
don't want
Well,
to show the whole thing to people at first.
I've learned it from you. I've learned it from you because we've been doing so many risk awareness weeks workshops. That's what you do. So I'm trying to replicate it. And that's, by the way, that's actually a very important point. I didn't realize that, but it's a very important point because in Excel, by taking somebody else's Excel and replicating their format and replicating the look and feel of the original model, it actually does something to your mentality and the mentality of other users. They find it much more acceptable.
Absolutely.
And, accepting the results of risk analysis is by far the most difficult part. It's not the calculation, it's the actual acceptance and usage. So building it inside somebody else's model is really overcoming quite a few hurdles already. So the next step.
Hold on, I gotta take notes. Just a second. Okay.
So the next thing that I've done is I have a simulation now. I have the full distribution sitting in each of the cells, and I can use ChanceTALK to tell me what's the average, what's the expected value is. And by the way, depending on methodologies, some people use average for expected, people use P50. ChanceTALK can do either. So you can decide on what your methodology is.
So this is the first time I really want to interrupt here. So risk is a horrible word. Risk is in the eye of the beholder. And so when it comes to something like this, expected value is important. And also you need some estimate of the tails. And you could use a percentile, or you could use the chance of exceeding something. So this first one, you see an average of 3.1. Great.
Yeah.
Well, you know what I'm worried about? I'm worried about the chance it exceeds 3.5, because that's when the wings come off.
That's a great point. We haven't finished. There's more. There's more behind the curtain. But yeah, that's exactly my thinking. For the contingency calculation, I went kind of halfway there, because what I've done next is I said, okay, if I know what the expected value is, I can calculate what's the expected contingency, which is basically the simulated average minus the original. That's the expected contingency, and that becomes kind of my minimum, something that is the minimum that we would need to include in the budget, but there's more.
Yeah, and then, that, by the way, is the flaw of averages number right there.
Yep. And it's even worse, because until we've done that calculation, there was no contingency at all in the model. Exactly. And so the next step that we do is actually we say, okay, well, what's the P80? And for the sake of the illustration, P80 is our plausible worst case.
Yeah.
What's the plausible worst case for that estimate based on the initial assumptions?
Yeah.
And then it gives us the percentile and allows us to calculate kind of this worst case contingency, and then allows us to see that kind of the minimum contingency we would want to have in the business plan is at least 5-6%, and then it could go up to 13 or more, and then the management kind of decides how much contingency they're comfortable with. And in fact, they didn't this time, but they could ask me, what's the chance of exceeding contingency of 10%, for example, or exceeding, some other threshold that they want to set up.
Exactly.
So this took me an hour to generate, and it has so many amazing benefits, because it allowed me to add, and I was doing a little working group with the Swiss risk community earlier this week, and I was trying to explain. Let me remove that from the screen so we can see each other. And I was trying to explain the difference. The traditional risk management is about quantifying the risk. And you create an environment where you try and quantify the risk. In my mind, that's a dead end. What we should be doing is we should be taking this uncertainty or volatility or risk and bringing it into the decision space. So
Oh,
we're
exactly.
quantifying the effect of risk on something rather than the risk itself. And most of the time, at least in my work, the risk is actually not of that much interest. It's more the effect the uncertainty has on production volume or prices or
Oh,
forecasts or costs or revenue and so on.
exactly. Exactly right. Exactly right. I mean, hold on. That's going to take us back to your quote about the board and Tuesday and Wednesday, whatever that was.
Yeah.
And in fact, that article at the Fair Institute came out since our last session here, so we should reference that article. That's
Yeah,
fair
I'll put
meets
it.
Sip
I'll put
math.
it below. I'll put it below
Yeah.
the
Well, we should
the
go out and
video.
look at the site because it's got that quote of yours on that, and it does help. It does help frame the whole question here. Okay, so that was a beautiful model. Well, okay, so may I respond to a few things here?
Yes, of course, please.
Well, that was lovely. Okay, first, let's go to, you mentioned static models. Now, things can be non-static in multiple ways. But just a minute, I don't bring my screen up yet.
Okay. And by the way, don't for everybody who's watching us, don't forget we're live, so you can ask questions, write comments, tell us if you share in the excitement, because I've been doing risk assessments and risk models in different forms and shapes for the last 18 years, and never have I been as excited as when I first saw Sip math as an option of bringing uncertainty into the Excel models. And now that I've actually started using it on a day-to-day basis, I mean, I have mini models like all over the place, and most of them, I've actually tried opening them on my phone as an Excel file, and it works.
And it works.
You can literally run Monte Carlo
Yeah.
simulation on some of the
On your
simpler
phone.
models
Yeah.
on the phone. Yeah, it's insane.
No, it's crazy. That is crazy. Okay, so let me just a sec now. I want to where do I begin? Hold on a minute. Oh, okay. So hold on. Let me start kind of at the beginning here. All right. So let's share my screen. Oh, you still there?
Yep, done.
I am now. It says you've ended the live session. No, I must. I bounced something. There we are. I got it.
No. You're live. Everything's good.
Got
we
it.
Can see the screen.
Okay. So here is the ChanceTALK summary, and I've got a list of things that Alex has said that are going to show up here, and I want to get back to them. The static model has meaning at two different levels, but let's start with this. So I claim, and by the way, I've been inspired by a lot of people over the years. Harry Markowitz, my dad. I mean, there's so many important people who've inspired me. Recently, probably one of the most inspirational, though, has been George Santos, the fraudster representative in the House of Representatives, because he has given me a new appreciation for bombast. and so but bombast with receipts. You know the expression, Alex, but I brought the receipts. Okay, good.
Yeah.
So I claim that Sip Math and the underlying discipline of probability management, really, which means storing uncertainty as data, it has ushered in a whole new intellectual era that I call the chance age. And for comparison, oops, wait a second, folks. Hold on, is this the right one? Just a second. I just had the right one up. Yeah, here we go. So let's compare it to the simulation age. The simulation age was ushered in 1947 with Monte Carlo simulation invented by Stanislaw Ulam during the Manhattan Project. In the simulation age, chances were calculated, and still are, by the way. The simulation age isn't over, right? Just because the Iron Age has passed doesn't mean we're not still using iron. That's very important.
Yeah.
So in the simulation age, chances were calculated by computer programs that generated random inputs to mathematical models. Okay. In the chance age, the chances are embedded in the data. So the data are called SIPs. SIPs, that's for stochastic information packet. SIPs are actionable, arithmetical, auditable, and agnostic. And I want to run through these each. By actionable, I mean, imagine you're making toast. And I go to you and I say, Alex, like in the US, you would need 900 watts of 60 cycle AC current. Now make your damn toast. You can't. You need the plug to make toast. So making decisions under uncertainty. Oh, you need a normal distribution with whatever. No, you need a SIP.
Yeah.
So SIPs are the electricity of probability. They are actionable. A SIP, think of a SIP as 1,000 or 10,000 trials that runs through your model instantaneously. And the fact that computers are so fast means it can be interactive. And this ushers in a completely different idea of analytics. I call it limbic analytics. You run the analytics through your limbic system by interacting with it. Okay, so SIPs are actionable. Remember, the SIP is the data that contains, say, 10,000 trials, could have 1 million trials. Arithmetical. So for those of you who know what a vector is, think of a SIP as a vector of, say, 10,000 Monte Carlo trials. And if you haven't, like when we did this work at Royal Dutch Shell, oh yeah, we've got the petroleum output of some exploration project, a vector of 10,000 trials. Yeah, then we've got a SIP of the price of oil. Oh, well, you multiply the two SIPs together and you get a vector, you get a SIP that represents the economic output of that oil site. So you're just doing vector arithmetic. And what it means is, the immediate thing is you can aggregate risk over a consolidated risk statement, right? The other analogy we've used is current risk models are sort of like sand castles. Let's move to Lego blocks. Okay, auditable? Yeah, it's data. And what we haven't described, and don't want to take too much time doing it, is that a couple of brilliant guys, Doug Hubbard and Tom Keelan, have brought in technology that I've managed to join together with my own technology to the point where we can in a sense, generate 100 million Monte Carlo trials in 88 bytes to build up random number generator. But it's auditable. It is auditable. So someone, well, Alex, like you deal with commodities. Oh, okay, we got the price of copper somewhere, right? And you now do a risk model at a factory somewhere. And you do a risk model somewhere else. And something doesn't seem right. Something doesn't seem right. It says, well, wait a minute. The model at plant B doesn't look right. And you go in there and you say, well, what was your price of copper on trial 7,842? Mine was, $12 a kilo or whatever the heck it costs, right? And the other guy says, oh no, mine was $2 a kilo. Okay, we got an audit trail going here. There's something wrong. Oh my gosh, I'm using the outdated price.
Yep.
The outdated price. Okay. And then, of course, it's agnostic. Oh, yeah. Excel, we can put it in XML, comma separated values, any format there. Okay.
Yeah. Well, I mean, I think by the time Risk Awareness Week.
Oh, I didn't mean to stop sharing there. Sorry.
Yeah, you needed to hide it. Yeah, let me read. But what I was saying is, I think by the time Risk Awareness Week comes in October, we'll be able to use and load SIPs into ChatGPT or some other AI, and even generate SIPs probably.
Oh, I think the AI story is really interesting here. Absolutely. That will be 2 or 3 of these sessions. We'll be discussing AI. Now, stop sharing for a second because I have to dig for something else. Because I got to go back to your first word, static.
Yep.
Okay. And so let me charge through.
In the meantime, I've shared the link to the Fair Meets Sip Math article, so people can have a look at it.
That's good. And why don't you bring the first one of those up on the screen, if you will? I'd like to actually share that with people in a minute.
Yep.
So get it ready to go. And now let's go back to your word static, and I'm ready to share.
1 sec. Done.
So here is an issue that we need to deal with. The bulk of people who've had a statistics course, and most people have had a statistics course in their careers, the bulk of them are left with what I call post-traumatic statistics disorder, or PTSD. And they are freaked out. And they don't want to talk about statistics. Give me a number. You're rolling dice. Give me a flat die with 3.5 sides. I'd rather have that than to have real dice. Okay. So here's a confidence building exercise that I do to desensitize people to PTSD. And I say, hey guys, I'm going to show you how to solve these equations, right? And they're freaking out. Oh my God, it must be the central limit theorem or Jensen's. What the hell is that? No. These are the differential equations of motion of a bicycle. Because the models are so fast, which we will demonstrate, that is instantaneous. You change something and it runs 10,000 trials before your finger leaves the enter key. Because of that, as I say, you can run it through your limbic system. And I call this limbic analytics. It connects the seat of the intellect to the seat of the pants. And my friend, the cartoonist Jeff Danziger, has done a lovely cartoon of someone connecting the seat of their intellect to the seat of their pants. And so when Alex says static, it happens at 2 levels. One, you can interact with it. We've talked about this story before. We had people at Royal Dutch Shell, 2 steps below the CEO, clicking on a model, which, by the way, not a risk model. It was an investment model, which of
Yep.
course had to represent the risk, which we will see as soon as you share the screen for that article. Okay, but that's only one level. The second level of not being static is that the model itself now is getting its probability distributions off some website that's being updated every day or every hour
Yep.
or every second or every 100 years, depending on what it is you're measuring. And you know you need to update it all the time. The final word on static is there are people who say, when will my model be done? That is akin to saying, when will my child be done? When they're dead. You don't want your child to be dead. Your child is growing. It's the relationship with a child. It's the ongoing growth and the surprises and things that go on for your whole life that are wonderful. So a model that's done is a model that's in the dumpster and has been abandoned. Do you have that other page now off the Fair Institute? Can you
I have it. I have it on your website.
Oh, here we go. Oh, okay, fine. So click on part 1. Let's just go out because I want to read your quote there, because it's so germane to what we're talking about. Okay. All right. So for people who don't know, the FAIR standard is like an accounting standard for risk. And the Sip MTH standard is like the Hindu Arabic numeral standard for numbers. Gee, our risks are accounting standards and numerical standards incompatible? No. What's incompatible is trying to use either one without the other, right? So here's Alex's quote, which I will read for him. Why do we receive performance data on Tuesday and risk management data on Wednesday? Shouldn't risk and reward be reported together? Yes, according to Harry Markowitz in 1952 and his famous risk return efficient frontier trade-off curves, of course they must be. And this article, co-authored with Engwee Yo from Kaiser and John Button from Gartner. If you scroll down, I just want to show one picture here. Scroll down into the article. And yeah, right here. No. Oh, actually, that's a good picture. The probability power grid. Okay. So at Kaiser, they used the FAIR ontology, which is like what is risk? You've got uncertain events that could occur with probabilities. When they do occur, bad things happen, right? And you have to blend those together and roll them up. That's the risk ontology, like an accounting ontology. And then they mix that with Sip MTH so they could blend it in with their investment models. Now let's see, what is the next? Oh, the next thing that I wrote down. This was the third thing, by the way.
Mm-hmm.
So we've been through 2 out of the 3. The other one that really struck me was using Sip MTH within someone's existing model. That is profound. They're used to looking at it. You just slip the uncertainty in. And I want to give you a nice analogy for that. You know what Dolby noise reduction is?
Yeah, I do know. Yeah.
It's a technology for communicating sound. Like Sip MTH is a technology for communicating uncertainty. And Dolby came up with this really neat way to improve the signal-to-noise ratio. And in the old days, I'm saying maybe the 60s or 70s, you could buy an electronic box from Dolby Laboratories, and it was a box that did this signal processing, blah, 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 whatever it is. Okay. Well, the bad news for Dolby is you can't buy a Dolby box anymore. The good news for Dolby is you can't buy a piece of stereo equipment without Dolby built in.
Yep.
And so it's very much like that. And that's a huge theme. Yes, if you have to build a separate model, and it's because you've got the data ready to go. Okay.
Yeah.
So,
but this is a huge issue. I mean, I don't think risk managers listening to us really understand kind of this mental jump, because risk managers are so used to building risk models for the sake of calculating risk, for the sake of talking about risk mitigation. It almost like they create the product for themselves. They are the sole user, and then they're surprised why the business doesn't really care about the conclusions.
Exactly. So let me give you an example. So we don't have
to
time
share
for
your
this
screen?
today,
Yeah.
but for our next get together, I want to talk about climate risk, which we know is huge and deserves 1 or 2 sessions on its own. But I'm involved now in a consortium involving people like the Aon insurance giant, the Government Finance Officers Association, the Pew Charitable Trust, and some other interesting nonprofits and organizations, in which we are trying to communicate climate risk. Now, so here's an example. This example has been around since before the consortium, but I just want to give you an idea of what Sip MTH can do. So we have a Shane Kavanaugh, who's been part of Risk Awareness Week, is the senior research manager at the Government Finance Officers Association. This is an outfit, this is a nonprofit that has something like 23,000 members who are financial managers of municipalities. And actually, Shane and I have been working since 2013, when we first incorporated the nonprofit with Harry Markowitz, to bring risk, not risk, we started with risk awareness. Now we're calling, it's chance awareness, basically, right? To city managers. And recently now, they've really been asking for climate and catastrophe related awareness. And so in this case, we're talking about a city that is worried about wildfire risk. And Aon, can you see my cursor there? Does that show up?
Yes.
Oh, no, here, down here.
Yeah.
Aon created SIP libraries of wildfire risk. Oh, that took 3 days to run. Yeah. We're not talking piddling models, right? 3 days to run. And typically, what would you get out of that? You get an average. So Aon would simulate a casino, a gambling casino, for 3 days, and out comes a flat die with 3.5 dots on it. Ridiculous. Okay. So, but they gave Shane a SIP library. And what we're looking at here is a city worried about depleting its reserves based on wildfire risk alone. Oh, well, we're going to have to add earthquake. That's right. But we can add them because it's arithmetical and we can just add up the Lego blocks. Okay. So if I look over here, I see the average reserves coming down and dropping negative here. And why is that? Well, I think, let me get rid of the percentile for a sec. I really don't need that on there. That was the 50th percentile. But this is an individual trial. So there's trial 1, trial 2, trial 3. Yeah, on trial 3, you have a giant fire in year 9, and that's why it's drags this thing down. Okay, so let me undo that. Okay, But now we're going to make a chance-informed decision. Oh, so let me define the chance age here. There is the flaw of averages that maybe you've heard of. You know, let's go back to the dice.
Yeah.
You're going to roll a die. The boss says, what number is going to come up on the die? That's really what they say. It's uncertain. No, give me a number, says the boss, right? And you say, well, if you need a number, on average, it's going to come up 3.5. And so the boss walks away with this, right? Now, you will get blamed when the die gets rolled and you don't get a 3.5. Bear that in mind, right? Okay. So in the chance age, when the boss says, give me a number, you say, what do you want it to be? Here are your chances. So the city is saying, we want our reserves to be non-negative. And on the right-hand side here, we have the chance of the reserves going negative by year. And by the time we get to year 10, we got a 10% chance, okay? Now, one of the things you might do is add to your reserve. So we have 20 million in reserves and a 13% chance of going negative. Well, what if I added 10 million to my reserve? So I bump that up to 30 million. Click. Oh, that was fast. How fast? Limbically fast, right?
Yep.
Here, Control Z, Control Y. 10. Oh, it's down to 10%. That's great. Okay, let's go back for a sec. Remember, we're the city council deciding what to do. Okay. Well, what else could we do? Well, we could buy insurance. The insurance is $1 million a year for 10 years. Well, if you discount that, that's even less than forking up the 10 million right today. Let's look at buying insurance. Wow, 6%. Yeah. We're talking limbic analytics here. And this consortium now, when you get to the full scope of climate change risk, it's gnarly. And the current Sip MTH standard would get swamped. But we have figured out now how to extend it. I'm telling you, you mentioned, Alex, you first saw this in 2019, and it just keeps growing and growing and growing. And so now this is actually a new chapter coming up. The first chapter was, and I want to, this was at the very beginning. I think it's worth showing this. The first chapter was, we can do it with dice, but by storing 10,000 die rolls. Takes up a lot of storage, but we can do it. And I can say equals that die on your mark, get set, go. Wow, that was fast. Yeah, that was limbically fast. How did that happen? The Excel data table became powerful enough in around 2010. I didn't learn it till 2012, that it could roll 10,000 dice per keystroke. And I can say, well, gee, what happens if we add 2 dice? And by the way, we're doing this in front of the board because they're all, life is a crapshoot. I mean, if you can't do it with dice, you can't do it with what they're really facing, right? And then someone says, oh my gosh, what would happen if we multiplied the dice? Why did it go up in the middle? There are more ways to get a 7 than a 2 or a 12. That's the central limit there. When we multiply the dice, oh my gosh, you get what you get. And meanwhile, the boss has said, we're multiplying 2 dice. What number are we going to get? But you go to the boss and you say, what number do you want to get? He says, well, I want it to be greater than 6. And you say 61.2%. And what is that? That is just a count if statement. All it is. So I want to give a good plug to ChanceTALK, which is this wonderful add-in that we've created that does not require the add-in to run these models. The models you've seen have been built with ChanceTALK. It's like building a birdhouse with a saw and hammer.
Yep.
The bird does not need to buy a saw and hammer. Previous simulation software has typically said, no, you got to buy the saw and hammer to use the birdhouse. So it is really revolutionary in that respect. And we must have. So
this was chapter 1. What's the new chapter?
Yes. So the new chapter. Oh yes. Sorry. This was chapter 1. Chapter 2. And let's see. I'm having trouble. You go out to our website. I want you to share here because I've got my. I can't share my. I'm going to stop sharing. Yeah. I'm going to. Oops. Yeah. Bring out your website. Yeah. Go to. Go to standards. Go to our website. Go to standards. Go to the 3.0 standard. The 3.0 standard. Very good. And scroll down. And so this is work with Doug Hubbard and Tom Keelan. And it's so exciting. It's like from 2 years ago. Scroll down to that gobbledygook. That is JSON down there. And so now we're able to represent the 100 million Monte Carlo realizations in this tiny little snippet of JSON code. It is truly amazing. Tom's Metalog is truly amazing. Doug Hubbard's random number generator, I wouldn't call it truly amazing, but it's great, wonderful work that is not his main line of work. And if Doug needs some, he builds it, right? Really wonderful. So that was the second chapter. And going back to the electricity analogy, if the dice are like direct current, then this is like alternating current.
Mm-hmm.
All right. The third chapter is something I call sparse Monte Carlo. And I've actually got a patent on some of this. So we don't know yet where this fits into the entire picture. But for climate risk, we've got to represent things in a different way because of the vast. I'm looking at Northern California. How big is the SIP library going to be? Oh, well, I mean, let's model it in 50-foot square little squares, 50 by 50-foot squares. Well, how many of those are you going to have? Millions and millions. And oh my God, we have learned how to do that. We and others have sort of figured out how to do that. And that's what the consortium is about. We should devote one of these shows to the consortium, frankly.
Mm-hmm, mm-hmm.
And then we'll discuss the climate risk stuff. And Aon is part of this, Pew Trust, and so on. And we'd like to get other insurance. Let me make it really clear what we're doing. We are not coming up with a better way to simulate wildfire risk. No, we are just conveying that risk.
Well, you're using the full distribution instead of the averages as they traditionally do.
But in this really impossible situation where you have millions of pixels, right? So we've come up, maybe this is like fusion power or something if we have to go to the next level. But let's go back to high tension electric transmission lines. They don't generate electricity. We don't generate probabilities. You can with ChanceTALK Monte Carlo, if you know what you want. No, the Sip maath standard transmits it. And the ChanceTALK tools help you both generate it and read it.
And integrate it into the overall business decision.
You can't build the models. You can't. Now I got electricity. Well, yeah, but I need vacuum cleaners. I need light bulbs. ChanceTALK is like a tool for building appliances. And we should devote a session to ChanceTALK as well. And by the way, so if you've got a web page there, go to chanceage.com. Just go out to chanceage.com.
Yeah.
So here's my self-portrait as father of the chance age. Oh, and why am I father of the chance age? Because I bought chanceage.com for $12.17. And by the way, at the same time, bronzeage.com was selling for $50,000. So go figure. But chanceage.com will take you actually to probability management and my webinar series. And we hope you will come to the webinars. It is a new age. It is a wonderful new age. And Alex, you've been part of it. And that's been fun to see all the progress. And I'm delighted. Your last model was just so beautiful. And let's do this again soon. And we've got a lot to talk about. We've got tools. We've got the new consortium that will lead to get new standards. And save the world, you know. I mean, it's kind of cool.
Thanks, Sam. Much appreciated. Keep sending through your questions and thoughts, and share this video. And we'll see you at the next Chance Talk.
Terrific. Okay. Bye-bye.
Bye, everyone.